Hello, good evening, guys. Welcome to 360 Digit MG interview preparation session. Give me a quick check regarding is the screen visible and am I audible to you? Give you a quick confirmation. Yeah. Yeah, friends, let us see regarding machine learning algorithms. How many types of machine learning algorithms are there? Let me write the question. Okay. How many types of machine learning algorithms are there? Anyone? There are three types of. There are three types of algorithms. What are those? The first one is supervised, and the second one is unsupervised, and the third one is reinforcement. Yes. Right. So these are the types of algorithms we use in machine learning. Okay. So if you come to the supervised algorithm, how many types do you find? What is supervised learning? Let me check what your answers. Yes, Divya, good answer. Now, my question is, what is supervised learning? Yes, I'm waiting for your answers. Here, supervised learning means supervised learning is a machine learning algorithm from labeled training data. Here, the output is known. What is supervised? Here, the output is known. Yeah. Yes, output is known. And if you come to the unsupervised learning, what is unsupervised learning? What is unsupervised learning? Unsupervised learning is a type of machine learning algorithm which is used to find the output of the given data. Of course, here also we have to predict the dependent variable. You can say dependent variable, nothing but the output variable or labeled variable, which is unknown. Here, the output variable is not known. Okay, in case of unsupervised algorithms, here for this, what do you say? The output is not known. Okay. Unknown output you have. Yes. If you come to the supervised learning, how many types of algorithms, learning algorithms popularly we use? Do you have idea? Do you have idea regarding supervised techniques? What we use basically there are how many types of supervised learning techniques we have? How many types? Basically, there are three types of supervised learning techniques are there. Algorithms are there, right? What are those? Those types I want. What are those types? The first one is, yes. What is the first one? Classification, right? And the second one is regression. Right. And the next one you can say ranking. All right. Yes. Okay. So like this supervised learning algorithms, types of supervised learning algorithms are classification type, regression type, and ranking type you have. For that, what are the names of those algorithms, exact names of those algorithms, what we have? Those algorithms are, let me check the box. Yes, Divya, very good. Predict output we use. Classification, regression, decision tree. Mhm. Here, popular supervised learning algorithms are, you can say, yeah, you can say here, like support vector machines, SVM, regression models, and Navi-based decision trees, KNN algorithms, and all. So what are the types of those learning algorithms? We have support vector machines, regression types, Navi-based, decision trees, and KNN algorithms. So the question would be, let me write the question. The question would be like, if anyone asks you, what are the types of supervised learning algorithms? How many types you have? Then what could be your answer? Yes, Viyam. Regression, Navi-based, decision trees, KNN. Yeah. Yes. Okay. Next question. If you come to unsupervised learning, what do you mean by unsupervised learning? What do you mean by unsupervised learning? Anyone, please? Unsupervised learning is a type of machine learning used to find patterns on the set of data given to you. Okay. And here we don't have any dependent variable or labeled variable in order to predict our output. Here we don't know about the output. So that comes under the unsupervised learning in machine learning. Okay. What are the types of unsupervised learning algorithms? My next question is, what are the types of unsupervised Yes. Okay. What are the types of unsupervised learning algorithms? What are the types? How many types you have? Generally, if you take, yeah, let me check the chart box. Clustering, yes, it is. Clustering, very good. You can say clustering, detecting the output variables, neural networks, and latent variable models comes under unsupervised, because in these algorithms, we don't know about the output, right? That's why. Okay, let us see about the Navy base. What do you mean by Navy base method? So where do you find Navy base? My next question is, what is Navy base? Navy base? What do you mean by Navy base? Anyone? If you see the Navy base classifier, it is a simple probabilistic classifier, right? The name itself tells Navy base means it applies the Bayes theorem. And here in Navy base, it assumes it takes some independent assumptions between features given to you. Okay, depending on the features of the data, it assumes some strong relations, probabilistic classifiers in between the features of the data. Yeah. Okay. Come to the next question. Okay. The name, the word name. What is the meaning of naive in naive base? My next question is, what is the term naive? Means in and B, naive base, right? My next question is, what is the term naive means in naive base? Anyone? Here, we call naive in naive base because it makes some assumptions, as I said in the previous question, it makes some strong independent assumptions. What type of measures, assumptions those are? It assumes that all of the features of the data which are present, all the features of the data set are equally important and all features are independent. Yeah, there is no dependency in between the features of the data set. It is the main assumptions. Naive means what? Naive means it is an assumptions. Okay, it is an assumption. What type of assumption it is? It regarding the features of the data set, right? Regarding the features of the data set. Those features of the data set equal, it assumes that all the features of the data set are equally important and all the features are independent, right? It is that's why naive we call in real world applications, and it is really true. It is optimistic and it is really true in our real world applications of machine learning algorithms. That's why we call it as naive in naive based machine learning algorithms. We consider these predictors are independent and all the predictors have an equal effect on the outcome, means all are important, all inputs are important for it, all equally affects the outcome, right? That's why we call it. Okay, fine. Now okay, here we are using machine learning, and you may have heard regarding the data mining, isn't it? Do you know the difference between the data mining and machine learning? Let me ask the question, like, what is the difference between data mining and machine learning? What is the difference between data mining and machine learning, guys? In data mining, what we do, we describe the process in which the structured data tries to abstract the knowledge or interesting unknown patterns and all. Okay. In that process, in data mining, what we do? Data mining, how can you describe data mining? You can describe data mining as a process in which the structured data tries to abstract knowledge or interesting unknown patterns from it. In that process, in order to get the knowledge from the data set given to you, or in order to understand the unknown patterns which are present inside the data set, we use machine learning algorithms. Okay, data mining means what? Data mining means the process on which we apply, where we apply that type of data mining process on the structured data in order to abstract the knowledge or the interesting insights which are present inside the data set we use. Okay, so for in that knowing process, in that gaining abstracting the knowledge in knowing insight, keen in deep, that data patterns and all, what we do, we have to apply some machine learning algorithms. Okay, what is machine learning algorithm? Means machine learning means what? It is a type of study, or you can say it is a development of algorithms designed. You have to design it, right? It is machine learning represents, it is a study, or you have to develop the algorithm in order to give the ability to process the in order to get the knowledge of the data. Okay, in order to give the ability, in order to provide the ability by using the algorithms, we have to provide the ability to process, to learn without any without leaving any insight of the data. Okay, so data mining means in that process of knowing the knowledge, in order to approach it, we use the machine learning. So you can say in data mining, we use machine learning algorithms for better approach, isn't it? Okay, whenever you see any algorithm, any machine learning algorithm, if you apply, what do you find? What difficulty you find? What is the drawback you find in case of machine learning algorithm once you apply? What machine learning algorithms you apply? Sorry, what type of issue, problem you face? You can say constraint. I'm not receiving any. I'm not receiving any answers from you guys. Why so? Yeah, here we got in machine learning algorithm, the main problem which we face is overfitting. What is that? Overfitting. What do you mean by overfitting? What do you mean by overfitting? Overfitting, where do you get it? Overfitting, you will get in machine learning when any statistical model be described. Okay, you will get some noise, or while finding the relationship, you will get some noise, or you will get some random errors. Okay, then overfitting is usually observed, isn't it? When a model is excessively complex, you will find this type of overfitting. Okay, why it is happening? Why? My next question is, why overfitting exists, or why overfitting occurs? Yes, right. Why overfitting occurs, guys? Yeah, please. whenever you find the overfitting, usually when can you able to observe it? When the model is excessively complex. In case of complex models, you will find the overfitting. Why it is exist? Why it happens? It happens because too many parameters you are concerning. Okay, you are concerning too many parameters. Number of in case of training data types. Okay, that's why the model displays poor performance, which has been overfitted. Isn't it? So what can you say? Less data, overfitting. Yes, Maurya. Here, overfitting, the possibility of overfitting occurs when you are considering many parameters for the training model, and because of that, it displays very poor performance. The model displays poor performance. That's why. Right here. So how can you avoid this overfitting? How can you avoid overfitting? How can you avoid overfitting? Yeah, guys. Yeah, overfitting occurs when we have a small data set. Okay, and the model is trying to learn from it. By using large amount of data, overfitting can be avoided, right? If there is no scope of getting large amount of data, then if we are having small database and you are forced to build a model based on that, then which technique do you use in order to avoid overfitting? Dheeraj Mishra, regularization, ensemble techniques. Simple. The answer is cross validation. You have to apply the technique which we apply. You are having a small data set. On that small data set, you are forced to build an algorithm only using on it. There is no scope of getting large amount of data. Then which technique do you use? You have to use cross validation technique. Okay. Again, my question is, what is cross validation? What is cross validation technique? What is cross validation? What do you do in case of cross validation? In this method? Here we, in cross validation, yeah, sampling we do. Here sampling technique means what? Here what we do? We take test data, train data. Again, first we take some sample, which is called the train data. We run the model, we run the algorithm on it, and the data set, we test it. Okay, we test the data. So what is the primary aim of cross-validation? Here, in order, what is the goal of cross-validation? The goal of cross-validation is to avoid the overfitting. Okay, here we are having very simple data. Here, test and train we have to do. And of course, here you can say and a regression, isotonic regression also be used in order to prevent the overfitting. What is that? Isotonic regression. Yes. Okay, as we are talking about algorithms and all. Okay, now let me ask one new question, that is what is PCA? Do you know about PCA? What is PCA? What is PCA? Yeah, Mishra, it is a dimension reduction. Okay. PCA means what? It is a principal component analysis. Okay, it is a dimension reduction algorithm. Principal component analysis, PCA. How can you do the reduction, dimension reduction? What do you mean by dimension reduction? Dimension reduction. How can you do the dimension reduction, guys? Dimension reduction means how can you do? Feature extraction. I see. Here, in which way, in which process it does, I mean to ask. Here, actually, what happens if you are having a data table, okay, any column or any variable is similar to the other variable, then there exists very little variation between the two parameters, right? So in between, if the little variation is existing between the two parameters, then automatically what happens here, the features are be reduced. Means what? The variation is very less. So PCA, what it does, it throws that variable out, and it considers the remaining one. Okay, means here, depending on the variation, it picks, okay, that particular parameter only it keeps. Okay, it is very useful as a pre-processing step, or especially when there are linear correlations between the features. Okay, when the correlations are existing between the features, it is very important. when do you use in real world? Where do you use PCA? In your real, next question is, where do you use, generally I'm asking, right? Okay, where do you use PCA in real world? Yeah, where do you use, let me see, eigenvector and eigenvalues? I see Dheeraj Mishra, only Dheeraj Mishra is giving answers. What about the remaining guys? PCA used in finance, in neuroscience, and in pharmacology. You use PCA, dimension reduction, okay, process. Principal component analysis. Okay. So why we are using PCA? In order to reduce the dimensionality of the large data sets, we use PCA. It's fine, it is okay. Then by using this PCA, okay, you are saying that you are reducing, let us make it a little bit complicated, right? So you are saying that you are having a data set. So by using the dimension reduction process and all, using PCA, you are going to reduce the dimensionality of your large data set, right? So how can be useful, how it is helpful to you in order to improve your performance, I mean improve the machine learning model, whatever you build, performance, how it will improve? That is my question. How can I write that here? I mean to ask here, okay, it is fine, you are using machine, you are using dimension reductions and all you are doing, okay, using PCA, you are applying, you are getting a fine data set, when you are having very large dimensionality, okay, large data set, okay. My question is, how it is going to improve your performance, your model build, whatever the model you build, machine learning algorithm, using machine learning algorithm, how it is gonna to improve the performance of your ML model? Yeah, question may be like, how does the PCA improves your model? Yeah, okay, this is my question. Who will answer this? I'm waiting for your answer, guys. Here, actually, what happens, PCA, of course, this principal component analysis improves the performance of the ML algorithm. You can say how. That is my question. Okay, it improves your machine learning model. How it improving? By eliminating the variables which are correlated. By that, what is happening? it don't contribute any decision making. It don't contribute in any decision making, and it helps in overcoming from the overfitting of the data. Okay, overfitting issues also you can able to come across. Okay, and also it decreases the number of features. By that, finally, you will get high visualization. It improves the visualization and high variance. Okay, so what is the thing is happening exactly here is, what the thing is here, from your large dimensional data set, you will get the smaller, simple original variables. Okay, it reduces the dimensionality of the data set. By that, what happens? There will be no decision making. There will be no overfitting issues. And here, decreasing because of the decreasing features, number of features, it improves the visualization also. By that, you can able to give the best performance of the model building. Okay. Yeah. All right. Here, my simple question. That is, is Pca supervised or is Pca supervised or unsupervised? Yeah, the answer is, it is unsupervised technique. It is unsupervised learning model. Pca is unsupervised learning model. Okay, similarly, I'm asking, Pca, is it linear or non-linear? Same. In the same way, I'm asking you, is Pca linear or non-linear? Is Pca linear or non-linear? It is linear transformation that transforms the data to a new coordinate system. Isn't it? So it is a linear transformation. Linear transformation means orthogonal linear transformation. It is, right? It is a linear transformation. Okay, fine. Okay, Pca. Okay, you are saying it is unsupervised and it is a linear. Now I'm asking you another question. Like how can you say, how can you evaluate this performance of PCA? How can you evaluate the performance of PCA, guys? I'm waiting for your answers, guys. Here, the one way to measure the performance of PCA is reconstruction error. Okay. What is that? That is reconstruction error. By calculating by measuring the reconstruction error, by looking into it, you can measure the performance. Okay. Let's look into. Okay, guys. Here, how many types of ML algorithms you have? Means name all those. No one is responding. That's why I'm asking you. You may know machine learning algorithms, right? So, how many types of machine learning algorithms? Just you name the name. Just you name ML algorithms. Okay. What do you know about ML algorithm? The names. How many names you know? Just you give me answer. Okay. Just you know, just you name. Linear regression, logistic regression, linear discriminant analysis, means a classification, regression trees, naive Bayes, KNN algorithm, SVM, so many algorithms we have, right? Hope all of you go through whatever the syllabus covered till now according to your sessions and plan accordingly and prepare well. All the best, guys. Thank you for attending this interview session. Have a nice day. Bye.